we're dealing with areas of a triangle. Two new formulas for finding the area of a triangle. Of course, you have your standard, how do you find the area of a triangle? 1/2 base times height. Okay, but if you don't have base and height, there are other ways of doing it. This is the first formula. This is the easy formula. Area is 1/2 AB sine C. Now, what this is, AB sine C, is if you have two sides and the angle between them. That's how, when this one works, when you have two sides and the angle between them, because A and B are the two sides, C is the angle between the sides A and B. So if you have an angle and if you have two sides and the angle between them, this is what you do for the area of a triangle. Okay. Then we have Heron's formula, which is a bit more complicated. And Heron's formula is if you have the three sides of a triangle and nothing else. Okay. The area is the square root of S times S minus A times S minus B times S minus C, where S is the semi-perimeter. Okay, and this semi-perimeter is 1/2 of the perimeter. Add the three sides, half of that. That's what the semi-perimeter is. Okay. It's not a complicated formula per se, but it requires a bit more arithmetic than most of the ones you have. But once again, this is if you have all three sides and nothing else. Now, if you really wanted to work hard, lessons, you could take any triangle that you have three sides of, and using the law of sines and law of cosines and your right triangle trig, figure out what the altitude of the triangle is, and then from there figure out the area of the triangle doing it that way. But that requires an awful lot of work. And the same thing goes if you have two sides and the angle between. You don't have the altitude. You can find the altitude, and you can go from there. That's actually where this formula is derived from. Okay, it's figuring that stuff out. That's what you're working from. Same idea. You can do the trig to figure out the area anyways, other ways, but it's nice to use these formulas to do that. So, find the areas of each triangle. First thing you want to do, draw and label the points. I have A, B, C, and this is a 36-degree angle, and this is 10, and this is 14. Once again, as usual, if you're not given a diagram, make a diagram. There were, unfortunately, a couple of people, whether this class or the other class, that on a couple of the questions, the one point they got on the question was they actually made a diagram, which furthered the answer of the question. If they hadn't made a proper diagram, they wouldn't have gotten any points, but they made a proper diagram. And that gave them one partial credit point, because it does further towards the answer. Okay. Now, from here, what do I have? I have two sides and the angle in between. Area is easy. 1/2 times 10 times 14 times the sine of 36. Okay, you punch that into your calculator. 0.5 times 10 times 14 times the sine of 36. And your area should be 41.1. And I don't give units, so I do not expect units in my answer. Not too bad, right? Okay. Second one, same idea. B, C, 8, 5, 10. What do I have? I have like three sides. So what am I going to do? I'm going to use Heron's formula. two parts to Heron's formula. First one, you do need to find the semi-perimeter. S equals 1/2 times 10 plus 8 plus 5. So your semi-perimeter in this case is 11.5. Now, the first thing you have to do is find the semi-perimeter. Okay. Now, the area is the square root of the semi-perimeter. The semi-perimeter minus one side, semi-perimeter minus another side, and then the semi-perimeter minus the remaining side. This is square root of all that. Yeah.
Order doesn't matter. Right?
Order doesn't matter. It's just the three sides. It really doesn't matter as long as you use all three sides. Just remember, multiplication, order does not matter. Multiplication is commutative. And you plug it in your calculator. Now, when I do this, I literally do what's underneath, type it in exactly as it is underneath the radical. Do that, and then take the square root of that number. I don't like to do the radical and then type the stuff in. I did too much of a chance for error. Now, if you want to do it by parts as you go along, 11.5, you can easily figure out the different numbers and then multiply those together and then take the square root of that. It doesn't matter to me. I mean, it's not like these numbers aren't hard to figure out. This is 1.5. This is 3.5. This is 6.5. You know, 11.5 times 1.5 times 3.5. You can do that if that's what you want to do. It's not that big a deal. And you work it out, and you get the area of your triangle is 19.8. Okay. Easy peasy, piece of cake. Not too bad. Like I said, I like these formulas. You could find the area doing other means other than these, using your trig and figuring out what an altitude, which one, you know, find an altitude. It's an awful lot of work. These are easier to use. Okay. Ooh. Find the area of the shaded region. Yeah, it's a piece of cake. Here's what you do. You find the area of your wedge minus the area of the triangle. And they're used to, and I know there's a specific term for this. And then you find the area of your slice. So you take the area of your pizza, you eat the cheese covered part, and then what's left over is the crust. We're looking for the crust. There's a specific name for that. I can't remember what it is. I really don't. What? It's not exactly. Okay, guys. So, first part, finding that wedge is something that you haven't done in a while, and you may not remember the formula, but it's not that big a deal. Okay. What's the area of a circle? What's the formula for the area of a circle? Pi r squared. And the radius in this case is 12. So I have the entire circle is pi times 12 squared. But I'm not having the entire circle, am I? Not 180. 360. Yeah, I'm doing a partial circle, so this is 80 over 360. My fraction of my circle. 360 degrees on a circle, I'm only concerned with 80 of them. Minus the area of the triangle. Well, this triangle fits one of our new formulas, right? Because we have two sides and the angle in between. Just all radii are the same. Yeah. 1/2 times 12 times 12 times the sine of 80 degrees. And you get 100.5309. That's what I did on mine. Minus 70.9061. And the area of our crust is 29.6. Boy, I hope that's not inches. Well, actually, it could be square inches. Yeah. 12-inch pizza. Well, it's not a 12-inch pizza. It's a 24-inch pizza. How much of the triangle are we trying to get? How much? So that's a wedge of a circle, right?
Oh, okay.
So pi r squared, pi times 12 squared, that's the area of the circle. 80 over 360 is what portion of the circle?
On the test, will you want us to go 4 decimal places?
No. Okay, shh, guys. That's a very good question. Do I want you to go 4 decimal places on the test? What's my final answer? 1 decimal place. When do I round off? At the end. So you should always carry more decimal places, more units in your work than your final answer. Because if you round off early, you might get round off error. Now for me, for what I'm doing on these tests here, if you're within a tenth, generally it's not that big a deal if I'm asking to round off to a tenth. If you did this on the AP test or on the AP Calc or even AP Stats test, if you round off too soon, and with the stats one, it's not as big a deal because you're not doing as many calculations per se. But if you round off too soon, you will get round off error and you will lose answer points. Seriously, it's one of those things. So you round off to 3 decimal places because that's what the standard rule is 3 decimal places. Well, if you round off to 3 decimal places in your work before the final answer, you might be good for the first 2, but not the third one, and you will not get the point if that third one's off. I've seen it in their examples that they grade, because they grade and have the examples online that you can look at and tell you what the scoring is, and I've seen it. And I've been in workshops where they say, no, this is why they lost that point. They did everything great, but rounded off too soon. And points are awfully hard to come by on the test. And because you lost a point, because you got lazy and rounded off a point, that hurts. Because that's what it is. Being lazy and rounding off too soon. Okay? Questions? So this one isn't too bad. Hardest part's remembering the wedge thing. Come on. There we go. Next one. Find the area of the quadrilateral. Now here's the thing with quadrilaterals. And all regular polygons, or actually not regular, all polygons, not just regular ones. You can make them into triangles. Okay, easy enough. You can make them into triangles and go from there. So I want to be able to do the top triangle and the bottom triangle. Top triangle is actually very easy to find its area. 1/2. 5 times 11 times the sine of 72 degrees. And so for the top one, I get 26.15 for the area for the top. Bottom, on the other hand, is a little bit more complicated. I do not have the angle measurement in between, so I cannot use that one. Nor do I have all 3 sides to use Heron's formula. Ah, there you go. I heard it. Magic words. You can find the third side.
Yay. Such a relief.
Label it X, find X. What would I be using for this one? Law of cosines on this one. X squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 72 degrees.
How do you use 72? That's not even a triangle.
Yeah, it is. It's in the triangle above. Because I have no angles down here. I have no angles down here. I can't guess what they are. All the sides are different. There's nothing regular about this polygon whatsoever. So I have to do that one. So I use that top one, and I end up getting X. And I rounded this one off to 10.6. I should not have rounded it off so soon, but I get 10.6 for that. Because you have to use the top triangle to find that line, but the line it's that diagonal is shared by both halves. Now I use Heron's formula. I figure out my semi-perimeter, 1/2 times 10.6 plus 7 plus 8, and you get 12.8 for your semi-perimeter. So the area of the bottom, square root, 12.8 times 12.8 minus 10.6, 12.8 minus 8, 12.8 minus 7. And you work all that out, and the area of the bottom half is 27.9999999. 9. And you add them together. The area of the entire triangle is the top half, 26.15, plus the bottom half, 27.999, and 54.1. Piece of cake. Okay. Question. Nice, short, easy lesson